Hello, I'm Paul Roberts and I'm a chemistry teacher here at Andover College. Today we're going to be looking at the core practical of combustion of alcohols and measuring their temperature rise. The alcohols we'll be looking at are ethanol, propanol, butanol and pentanol. This experiment is fairly straightforward. However, I'm going to show you some tips along the way to get some clean, accurate results. Regarding safety in this practical, you're obviously going to be handling a wide range of highly flammable alcohols. There are also specific hazards associated with these alcohols. More information of these can be found on the CLIAPS website. This core practical requires you to measure the temperature change of the water when the alcohols ethanol, propanol, butanol and pentanol are combusted. For this demonstration, I'm only going to carry out the combustion of ethanol, as the other three alcohols will be combusted in the same manner. To start off with, I'm going to measure and record the mass of the ethanol spirit burner, taking care to weigh the burner with the cap on. Next, I'm going to measure out 100 centimetres cubed of cold water into a measuring cylinder and then add this to the 250 centimetre cubed conical flask. The conical flask is then clamped around its neck, and I'm going to lower the base of the flask to around 5 centimetres above the height of the burner, which is on a heatproof mat. You may choose to use draft shields to ensure more efficient energy transfer. However, for the clarity of this practical, I'm going to omit any draft shielding. We are now ready to start the experiment. Firstly, I will place the thermometer in the water bath. It is briefly stirred and then left for 30 seconds. After this time, the initial temperature of the water can be recorded. Next, we can start the combustion. Making sure the burner is directly underneath the conical flask, I'm going to remove the cap of the burner, and without delay, I will light the burner, taking care not to knock off any pieces of wick. It is important that this stage is done promptly, otherwise the alcohol will evaporate from the burner, leading to unreliable results. Whilst combustion is taking place, it is important that the water is constantly stirred and the temperature is monitored. Failure to stir will result in hot and cold spots in the water and produce unreliable results. Once the temperature has risen by approximately 40 degrees C, cap the burner. This means if my initial temperature was 20 degrees C, I would cap the burner when the temperature of the water bath reached 60 degrees C. Because the base of the conical flask has been exposed to the flame, it will be hotter than the water. It is therefore important to keep stirring the water even after the flame has been extinguished. Expect the temperature to rise slightly more and record the maximum temperature of the water. When you measure the temperature, ensure the bulb of the thermometer is below the water line. Resist the temptation to remove the thermometer from the water to enable easier reading. Once you've recorded the maximum temperature of the water, you can now weigh and record the mass of the spirit burner, including the cap. Now at this point, we have a conical flask full of hot water, which is a hazard. As a tip, you can add 100 centimetres cubed of cold water to the flask, which should cool it enough for you to be able to handle safely. Pour this water down the sink and rinse the inside and outside of the flask with cold water to enable prompt cooling. You can now repeat the experiment using the other alcohols, propanol, butanol and pentanol. Try to use an identical experimental setup for each alcohol, ideally with the same gap between burner and conical flask, the same draft shielding, and if possible, a similar initial temperature and temperature rise. Now at the end of the experiment, you should have a range of differences in masses and a range of temperature changes for the four alcohols you've combusted. You should also be able to see a trend in which alcohol requires the least mass to produce a particular temperature change. So to summarise, I've shown you how to set up your experiment carefully, which has enabled you to get safe and accurate results. We've also shown how you can measure the combustion temperature change of one alcohol and use this as a template to obtain other results.